the imperial ultimate science. It's science. There's black Mr. Person and the other guy. It's science. Yeah. Woo!
Alright, so today's video is about plate tectonics, and specifically we're going to talk a little bit about all the different plate boundaries.
Yeah.
Before we even get into that, though, we got to talk about what is plate tectonics. Well, it's a theory. Now keep in mind, theories are well supported by evidence. But remember we talked about lithosphere and asthenosphere. The lithosphere, which is the crust upper mantle, is broken up into sections called plates. So you can see down there, there's a picture showing there's like a big North American plate that, you know, has most of North America and some of the oceans.
These are slabs of rock,
Yeah.
right?
Yeah.
Giant
slabs
of rock.
We're talking
bigger than
huge,
our continent slabs of rock.
Basically floating on that liquid layer, right?
Yeah,
That's awesome.
there are about 16 major plates. There are a few smaller ones in there.
Okay.
Here's a bigger picture showing all the plates if you want to take a long look at it, but we're going to keep moving. Now, the whole idea is that these plates move around. Now, you might be asking yourself, okay, how do they just randomly move around? Well, if you remember, I was talking about the asthenosphere. Within the asthenosphere, there's a circular movement of that kind of semi-liquid rock.
Molten rock, yeah.
As it moves and it moves, it pushes at, say there's a plate here, as the liquid rock rises, kind of pulls at the plates and makes them move.
Yep. And the reason why it does that is because as it rises up, it's hot, so it rises, and then it gets towards the top, it cools down, which makes it more dense and falls back down, and it's that falling that pulls it.
Like a lava lamp.
Like a lava lamp.
So as it gets closer to us, closer to the crust, it cools.
Yep.
And
as
that's
it
what
gets
makes a
more-
little circular motion called convection currents.
So think of it if you had a hot air balloon and you kept, like we all built them in this class,
Yeah.
you somehow had a mechanism where it heats up and then cools down. And then when it gets to the bottom, it heats up again. So it keeps
Oh.
going up and down, except it kind of goes in circular.
Yeah, okay.
But that motion below those plates is what makes those plates move.
Cool.
Okay, so
Okay.
there's currents just like
So-
in streams.
So here's like a little step-by-step. Someone else can
Right,
talk
so
about it.
so this is what we were just talking about. So at the first, you have, if you look on there, it says hot molten rock rises up because
Okay.
it's less dense than cooler rock. So hot goes up, whoop,
Away from the core.
away from
Okay.
the core towards the surface, and then as it reaches the surface, it pushes up, and it kind of basically comes in contact with those slabs, and because it's moving, it's a fluid layer, it's going to grab and kind of pull almost like
Yeah.
a gear system.
And the reason it moves is because it gets to the top, more rock is still coming up.
Right,
I
so
think
it's
I'm
like
not in the
pushing
camera.
it out of the way.
So it pushes it to the
Pushes it out of
side.
the way.
Sorry, I almost hit you there.
No, that's fine. I should make
It's all in the name of science.
And then eventually what happens is as it kind of keeps going, that rock cools and it starts to sink back down, and then the process just basically starts all
Yeah.
over
As
again.
it cools,
Yeah.
it becomes more dense. I
Yeah.
get that.
Yeah.
It's all density on this.
All
This is
density.
neat, density and
Yeah.
temperature.
So this is the process that pushes basically everything we're about to talk about.
Moves the
Yep.
whole planet around.
Cool.
All
So
right.
you got these things called plate boundaries that form as a result because you have the Earth plates, they're constantly moving, crashing into each other, sliding, pulling apart, and whatnot. The area where two plates meet, any two plates, is called a plate boundary. Okay, it's just like where they meet. So like where my hands
up
are,
against
the
each
line
other,
in
and
between,
that's the
that's your
boundary.
boundary.
Just like a boundary, we have a boundary just north of us between Illinois and Wisconsin. Boundary
Yeah,
just means
anywhere you draw a
spot
line.
where you're drawing a line.
Yep.
This is where two things meet.
And you separate.
Yep.
And there's three main types of boundaries we're going to talk about. One is convergent, then we have divergent, and then you have transform. And we're going to go into those in a lot more detail as we kind of move through.
All right, cool.
All right, convergent boundaries. The first one we're going to talk about. When something converges, just like we had just in our waves unit, when it converges, it comes together. So it's a boundary that's formed when two plates move at each other. They're moving towards each other. And convergent plates, they have this thing called sometimes subduction. And sub means under, and induction is kind of this movement or transfer. So what happens is you get a transfer of one plate underneath the other one.
Yep.
So they collide, and instead of just like smashing, one goes under the other, and this forms volcanic mountains because there's a gap here that lets lava up. Here's the mountain, and lava shoots up through here, and you've got your volcanic mountain.
Right.
Now, you can also have convergent plates. They come together, but no subduction. When these guys collide, they stick and they block that area up, so
Yeah.
lava doesn't come up out of there. Magma doesn't come from the ground, but it still makes a mountain. So convergent plates smash together and make mountains.
Yep.
Think of like, two objects when they come together and they try to occupy the same place, they're going to kind of pile on each
Yeah.
other.
Right.
Okay, so
Pushing
that's
They got to go somewhere. The force
Yeah.
is going to push these
that's
guys
why
up.
something goes up.
Yep.
Okay, but
Look at the next.
anyway, so there's a way of actually classifying these convergent
Okay.
boundaries, and you see subduction in some of these, you don't see subduction in some of these.
Okay.
Now, the first one is called an ocean-ocean convergent boundary. This is when you have two plates that the boundary is actually underneath the ocean.
Underwater.
So there's
And
water
here-
all over the
yeah,
top.
you have water on this plate, water on this plate, and as they collide, this usually results in subduction where the more dense plate goes underneath,
Yep.
and it actually forces magma up
Volcanoes.
Makes volcanic
And then, of
mountains.
course, it cools in the
Yeah.
water, and it makes volcanic islands like the
Yeah.
ones in the Philippines, Japan,
Yeah,
and some
Japan
of these
was formed
places.
this way, yeah.
Well,
It's just
Hawaii's a
molten
little
rocks,
different.
boop, boop, boop,
Yeah, Hawaii
and
is
Hawaii
different.
is another
Hawaii's a
one.
hot spot. No, Hawaii's a hot spot.
Yeah.
That's
Really?
it's
Yeah.
a little different.
Yep.
Interesting.
We'll talk about that one
Yep.
in another
That's
video.
interesting.
But anyway, then an ocean-continent convergent boundary means you have an ocean plate and the other plate is a continental plate, meaning it's all land on this one. And this one also usually ends in subduction. The ocean plate usually slides under, okay, and it pushes lava up and blah, blah. And this is why, actually, if you go out west, because there's an ocean-continent convergent boundary, there are lots of volcanic mountains, like Mount St. Helens, Mount Rainier,
Yep.
Mount Hood.
Cascade Range.
Yeah, Cascade
And
Range,
all
yep.
down the western coast of South America.
True.
Yep.
So,
Now, go ahead with this
Yeah,
one.
the last type of convergent boundary is continent to continent, and that's two solid rock masses, basically landmass. Yep, come together and they collide. And here you do not get subduction because neither plate is. They're both basically equal in terms of density, so neither one wants to go under. So they just push and you get lots and lots of really tall mountains. This is usually where you get your highest mountains.
Yep.
And this is gonna be like places like the Himalayas. Think there's the India plate smashing into everything else, and you're getting these huge tall mountains out of it.
Yep.
cool.
Yep. So now we talked about convergent boundaries.
And
Mr.
now
Harkins, you want to talk
other
about
one.
divergent boundaries?
It's divergent, just the opposite, go in the other direction. So when two plates actually pull apart from each other, because remember, this movement's happening all over the planet. Some are going towards, some are going apart.
Right.
In this case, they move apart, and of course, there's magma underneath here, and it's going to bubble up through the space that they've left by moving apart. And it fills in that gap, and it makes basically a new crust in there, like kind of like we had at the Mid-Atlantic Ridge.
Right.
Yep.
So
I
you
got a
have
picture of that
certain
right here,
areas.
actually.
Yeah.
Yeah, so
And as
you
they
might
move-
notice if you look at like Google Earth, you'll notice looks like there's these underwater mountains that they've put in.
Yep.
And what
That's
that's
the
marking is the
Mid-Atlantic
Mid-Atlantic Ridge where the plates are pulling apart.
And that's also why Europe and the United States are getting away from each other
Yep.
slowly but
Yep.
surely.
Yep.
Going
The
around
Atlantic
the other
Ocean's
side.
actually getting like 2 inches larger every year.
Yeah.
Yeah,
It's like-
it's
it's
about
like
3 to
4
5
to
centimeters,
centimeters, yeah,
something
about
like
that.
that. It's right
Yeah.
around there.
Yeah.
And so the magma comes up and it cools in the water and it makes mountains.
Cool.
So
The
hit us
last-
with transform.
Yeah, the last type is transform boundary. And transform boundaries are when instead of plates like running into each other, they're sitting next to each other. And what happens is they just slide past each other. So basically they're next to each other, and as forces build up, they go and they kind of slip. And that's usually
Yeah.
when you get earthquakes, which we'll talk about later. But basically, two plates next to each other, instead of smashing, they're just sliding along
Yeah.
next to each other.
This is where the famous San Andreas, the
Yep.
San Andreas Fault, which is what goes up the west coast of California.
Yeah, and-
As this like, and actually, I like this picture on the left.
great.
It's like a farm where it was nicely like
Tilled.
groomed, tilled. Is that the word?
tilled.
And there's it was right on the San Andreas Fault, and the plates shifted, and you can see
can
that
see
the
where the
lines
lines
are
have
kind of
shifted.
displaced
Yeah,
by a few
definitely.
inches.
Kind of cool looking, definitely
Yep.
weird.
So that is
Right.
it.
Those are
yeah, I know that
boundaries.
was vocabulary heavy.
Yep.
Make sure you use your notes while you go over your checkpoint.
Yep.
Do your checkpoints, guys.
Checkpoints.
Kick butt. Kung Fu. Wah!